Hi, welcome to everyone. Today we are looking at Paper 2 from IGCSE Computer Science with a specific focus on the database section. We'll start by having a little look at the learning of the content quite quickly and then how that relates to an exam question for each of those sections. I'll put a listing below of the timings for each section. So, feel free to skip to the bit that's most relevant to you or watch the whole thing if you have no idea what's going on yet. But the database section is about 10 to 15 marks of any Paper 2 and a pretty easy way to guarantee some quality marks. So, let's get started. What is a database exactly? Well, take a look at this information that's right here. So, when we have a store of data together, it can be organized in different ways. Look at the way that this is specifically organized, the columns and the rows going across here, and also the order that the data is taking. As well, how is it all stored in fact, inside of this boxy looking area that we are commonly known as a table. So, a database is just a collection of data that is organized in a structured row that we put into a table. It has columns. It has rows. There are categories of the organization that we've sorted the data based on something important like price. It is a collection of data organized in a structured way. In the IGCSE and within a database as a subject and topic, and it's an application you use. There is some specific terminology that we're going to want to know and understand. So, first of all, tables. Every single database is made up of tables. Here is a table right here. This table has rows going across. These are called records. We also have these categories up at the top here which form each column, and those are our fields. So, you can see the fields listed across the top here for each sort of category of information. Now, a really common question that you will get in the computer science exam is, how many fields and how many records does a table have? So calculate that. For me now, how many fields and how many records? Now in your exam, you're going to be dealing with what we call a flat file database. So, that means it only has one table. That's all you'll have in your exam, one table. So, do you have the answer now for me? How many fields? So you just count the number of categories at the top of the number of fields. There are 7. How many records? Well, these records are the rows that go across. Think about it like a school record, like you have a permanent record, a record that is about you, and it has lots of categories of information all about you, like your name, your age, your address, the subjects that you study, anything naughty you might have done. All of this is listed across and forms one record. So, how many records? Will we just count the number of rows here? There are 14 records in this table. There you go. You just got your first 2 marks. Now we mentioned that a flat file database has one table. Well, a relational database has more than one table. So they have 2 or more tables that are joined together by key pieces of information. Take a look at these tables down here. This is an example of maybe something like IMDb, or it could also apply to maybe music libraries. We have these huge databases of information. We use them all the time. Anytime that you're streaming something, searching for Netflix, you're looking on YouTube. These are databases of information that are categorized together. You might want to search for a certain actor, or you might want to search for a certain film. So, when we look at these tables and how they join, I mentioned that they're joined by a unique field. You see this key here that indicates. This is what we call the primary key, and every table has one of these primary keys. It is a unique identifier that does not contain any duplicates, and it cannot be left blank. So, again, if you think about your school, you probably have a student ID number. Your email address might even be your student ID number at your school name and your country domain. This key piece of information is what allows us to join tables together and to have just a unique identifier for records. It is essential for every single table. Okay, now in this table, which one is the primary key? So, take a look at this table and tell me. One of these fields is a primary key. It must have data, so it must have data in it. It cannot be blank. It is a unique identifier and it does not contain any duplicates. So if you get a question about this in an exam, you need to take a little look down here and see well. Look at this, there's a lot of yes, no's in here. There are a lot of repeating FTs and CVs. Sometimes we have the same screen size, things can be the same price. What we're looking for with a primary key is some sort of identification number, and that is normally what an ID number is. If you're asked to suggest a primary key, you're going to want to come up with some sort of ID number based on whatever the topic in the scenario is. So, let's take a look at the examination questions. This is a past paper question, and it's a nice simple one to start with. How many fields and records are in this table? Answer it by pausing the video. Answer it real quick. The fields are going across. 1, 2, 3. There are 3 fields in this table and the records are going down. 1, 2, 3, 4, 5, 6, 7, and 8. 8 records in this table, 2 marks, nailed it. Here's another exam question from the same table. This time it wants you to explain why none of the fields in this database can be used as a primary key. Feel free to pause it and answer it. Now write yourself a question down and then we'll go through it. A primary key is something that has to be a unique identifier. It cannot complain to you contain any duplicates. Okay, if you look at each of these, well, here is 129. Immediately there's another 129. I've got 2 25s. If I look in here, I've got 2 toys, 2 shoes. I've got 3 toys, and even over here the name, well, Jane Smith is in charge of both toys and shoes. So, there are duplicates in every single one of these fields. So, if you get this question, why is it not good for a primary key? Just have a look and find the duplicates and see that there will be no field that does not have a duplicate inside of it. Alright, another question on this same table. What could we use as a primary key instead? So, nothing here is good for a primary key. What we need to do is take a look at the scenario. Read the scenario and pause it now if you want to write an answer. So a database, STAFFPHONE, was set up to show the telephone extension numbers of the members of staff working at the department store. So, how could I uniquely identify? I would go with some sort of staff ID. So, if it's about staff phone, what would be a unique ID? Well, it could be a staff ID. So I would go with a staff ID. That's mark number 1, and then the reason is that the table is about staff and it's a unique way to identify each staff number, each staff member. Sorry, so no member of staff will have the same ID number and there are no duplicates. So just like in programming, when we handle data in a database, we need to assign a data type. So, when we've had a variable, maybe we would make that a string data because it's going to hold text, or we might make it into a float because it needs to be able to complete decimal calculations. Exactly, the same thing. So one of the main questions that you're going to get is about assigning a data type to each field. By all means, pause this and take in all of the different data types here. But let me just outline which are the most important to know. It's a little more simplistic in this section than with programming. So, let me just jump down here to these 3. So here I'm mentioning numbers, and that's any type of numeric data. Now you'll be used to having integers and floats. So, you are used to separating a whole and a decimal. In the database section, you can just categorize them as the number, and it can be used for both the real and the integer. So it's even easier, but if you want to call it an integer or real, they will accept it. But you can just put the number in the same way for alphanumeric data instead of using a string, which is what you might be used to. You can also just say text, but any of those would be accepted: alphanumeric, string, or text. I like alphanumeric. They will accept text and you might be used to string. So, make your choices, but you can categorize the number ones together, especially if we have a date and time. For any date and time data money, you are not going to select a decimal in the same way that you might have done if you were doing programming, because we want to be able to assign it formatting based on its currency. So think about databases that produce reports, and the reports are from querying or searching the data. The presentation of those reports can be formatted to include certain currencies or a format of the date. We have a separate field category for this separate data type. Then the other important one is the Boolean. Now you know Boolean already. You are used to using yes, no, true, and false data. We studied it in computer architectures. You understand it from the logic gates. You know what it means to have an on, off, yes, no, true, false value, and that is the Boolean field. We're going to go through some questions now to help you. So, let's take a look at this first field here, TVID. It's the same one from before. This is alphanumeric data. It contains text and it contains numbers. So, we would categorize this as an alphanumeric. Next to that, we have screen size. Take a look at those numbers. Oh, I said numbers. Is that a number in there? Well, yes it is. Are those numbers organized in some sort of way that we have handled the data, and why? Yes, we have this numeric data, and it can either be used for calculations on number handling, sorted very nicely by largest to smallest. This is a number field. Next is the 3D. So that is a yes-no category. Yes, no, on, off, and true, false are 2 options. Boolean. Curved and flat letter data. Letters are alphanumeric. They are text. So it is a text or string alphanumeric field. Next, we have the internet. Why, that's another yes no. Yes no and true false are Boolean. What's next? Well, it's HDD. So, is this a high definition? Yes, it is, or no, it's not. Yes no, true false are Booleans. Lastly of all, the price. So our price is a type of numeric data. But it's specifically formatted. Look at that $sign right there. This is money data, so it is a currency field. So we've got alphanumeric, number, Boolean, and currency. We didn't have a date and time here. But I'm sure that you're going to recognize that when it comes up. Let's go at this question. Pause the video, try and put in the type of data for each of these fields. Take a look at this bit there and read the descriptions that they are giving you, because that will help you to understand. So in this one here, arrived, does not mean yes no, it has or it has not arrived. Read the question carefully. Pause the video. Put your answers. We'll see how you do. Let's look at those answers. So, first of all, is the title. Both the title, the artist, and the description are going to be text fields. Because they are alphanumeric, you could potentially use a memo. If you don't know what memory is, it's just a larger amount of text that is allowed. Because in a database we set the field length to reduce the size of the database file. But if you don't know the memo, don't worry, it's just a larger size. So next coming up is the catalog number. Now this one is a little bit of being careful with this, because you assume that is likely to be a primary field. Essentially, this is likely to be the primary key. It's likely to be the identifier that doesn't need to be handled as number data. So it might not be a number. It might likely be an alphanumeric field like CN4789 or CN674. You know, it could be like a mixed text and number. So I would just put it straight away as text. But if you've built a database, you may also be used to using an auto number for your primary key, and technically it does say catalog number. So you could put a number and it would be acceptable. Next is size. The size is the area in square centimeters. So that is a numeric value. We will mark that as a number. Next up is price. Price is about the money and the money formatting. So that is a currency field. Arrived, it's not yes no. Arrived is the date that the picture arrived at the gallery, and so it will be a date and time field. Lastly is sold. Did that picture sell? Yes or no? Is it true or false? Did it sell? It's a Boolean. So the last question here is, which one of these would be the primary key? I did technically already give you the answer to this question. So it's going to be whichever is the unique field and the unique identifier. Here it would be the catalog number. So right, there are 5 marks, very easy. There are 5 main data types to remember and the definition of a primary key. You're winning for this section. So next are validation rules. Now you will be used to using validation in your programming. Also because you will have probably programmed to make sure something is in the correct range or it's the correct data type. So we do the same thing in databases to make sure that the data that is entered is valid, which means is it sensible, reasonable, is the correct data type, is in the correct range, is the field not blank, things like this. So, let's run through the key validation rules that you need to know. You might want to pause it as we go through and soak these in. So, first of all, is a type check. That is a specific data type. So make sure you've set it as currency. We're only accepting number values, like you can't type out $3,000. You're going to have to put, type out words. You're going to have to write 3000. Next is a length check. So that would check that the data is meeting a set number of characters. So if it has to be a 4-letter code, a length check will ensure that a format check will make sure that it is meeting the correct formatting requirements. So for example, if you had a date and time, we have a difference between an American format and a British format, or using a long date and a short date. So notice, there's no 0 here and it's just 21 instead of being like 09 and 2021. So put it into the correct format that you choose. Presence check just means the field could not be blank. That's a great one to put on a primary key, by the way. Range check, you'll be used to this one. That is making sure that the data is within a specific range. By all means, pause it, soak this in. Let's go and see it in an exam question. I think that's going to help us out. So the most important thing to remember with an examination question is that you cannot use the same validation type twice. So don't go down every single one of these in range check or type check. You have to do a different one for each one. So, think about that carefully when you're choosing. Read the description of the question again and let's have a look. So the first one is the catalog number. That is a primary key, and as I mentioned in the previous one, I would just instantly put the presence check in this one because a primary key cannot be blank. So it's the easiest one to use presence check for. Next is size. So I would make that into a type, because the size needs to be numeric. Specifically, it is in square centimeters. It must be a number. So I would use that for type 1 because when it comes to these